Hey guys, welcome back to my channel. In today's video, we are going to see this problem called print all nodes that doesn't have siblings, right? So given a binary tree of n nodes, find all the nodes that doesn't have any siblings. You need to return a list of integers containing all the nodes that don't have a sibling in sorted order. So we have to return the answer in sorted order. So basically what I'm going to do, I'm going to pick those nodes that doesn't have any siblings, and then I'm going to sort those nodes and return the answer, right? So let's understand the question first of all. So first of all, what is a sibling? So let's say one parent is there, and this parent has one child, or let's say two children, right? So let's call C1 and C2. So I can say that C1 and C2, these both are siblings. Why? Because they both have same parent, right? So that's the reason C1 and C2. C1 and C2 are siblings. So children of same parents are called siblings, right? So in this example, let's take this as a parent. So one has two children, 2 and 3, right? So 2 and 3, these both are siblings. So 2 and 3 are siblings. Now let's check for 4, right? So who is the parent of 4? 3. So 3 has 4 and what? 4 and nothing. So 4 is there, but 4 doesn't have any sibling, right? So 4 is a node that doesn't have any siblings. Similarly, 5 also doesn't have any siblings, right? Why? Because 4 only has one children, right? So 5 doesn't have any sibling, right? So similarly, let's check for this. What is this? This is root, right? So can root be a sibling? Can root be a sibling? Who is the parent of this root? No one, right? So root cannot be a sibling. Why? Because root doesn't have any parent, right? So let's check for this. This node has a parent, this guy, and this node also has the same parent, right? So I can say these both are siblings. So we got to know two things, that is what is sibling, and then root cannot be a sibling, right? So let's understand what is the intuition. To be very honest, there is no intuition. I mean, it's actually a straightforward question. You just have to traverse it and then check for the answer for each nodes, right? So let's say I'm standing here and I want to check whether this is a sibling or not. How to check? Can I check? No. Why? Because see, if I have to check for this, I have to stand here. I have to stand here. Then I will say, bro, do I have only one child? If it is, then that child doesn't have any sibling. But if no, that means I have multiple children. So in this case, there will be two children because it's a binary tree. So they both will be siblings and they cannot be the answer, right? So I will stand here, then I will check for this and then I will check for this, right? So if I have only one child, those children cannot be a potential answer, right? Because they will be siblings. So what I'm going to do, I'm going to traverse through all the nodes and check for the answer, right? So I can do it by using DFS and also by using BFS, right? So how I'm going to check? So let's look into the possible answers, right? So let's say a parent is there and the parent has one right node, but left node is not there. This node is a potential answer. And let's say a parent is there and parent has one left node and right node is not there. So I can say this node is a potential answer because this node doesn't have any siblings, right? So these two are the two conditions that we need to check to get the answer, right? So in short, I will simply traverse through the tree and then I will check for these two conditions, right? So let's look into the code. So here I have done DFS. You can also go for BFS. So I have declared a vector for returning the answer and then I'm just calling DFS function, right? So inside this, it's a normal DFS. But while doing DFS, I'm just checking for these two conditions, right? So let's say node left is there, but node right is not there. Then I will store the data that is there in the node left and then go ahead. Then let's say node right is there, but node left is not there. So I will just store node right data into the answer and then go ahead, right? Rest is a simple DFS. So I'll be going for left node and then right node, and the moment node becomes null, I will just return back. So at the end, answer will be having those nodes that doesn't have any siblings, right? So we have to sort this answer and then return this. But in the question, it says that if there is no answer, then we have to return -1. So that's the reason I'm checking here. If the answer dot size is equals to 0, which basically means answer is not existing, then I will just return vector of -1, or else I will just return answer itself. So talking about the time complexity, this DFS call, no, this DFS call takes of n space, so of n plus this sorting function takes of n log n space, right? So it will be of n log n. Ignoring this, I can write of n log n will be the time complexity. So talking about the space complexity, I'm taking of n. Then you might be wondering, bro, of n how? So it's the recursion call stack space, right? So call stack space. But still, how of n will come for a Q tree, right? For a Q tree, the height of the tree will be the size of the recursive call stack, right? So at the worst case, this Q tree will have of n space complexity, right? So space complexity will be of n. So that's it for today's video. If you like the video, hit the like button, subscribe to my channel. Until next time, see ya.